Hi, this lesson is about the average rate of change. The average rate of change will be the change in the y values divided by the change in the x values when you are considering the average rate of change over 2 points that I'm calling x sub 1, y sub 1, and x sub 2, y sub 2. It is basically a slope calculation that you may already be familiar with. So if I asked what is the average rate of change of a function f of x between x equal to a and x equal to b, then that just means that you have to plug in the x values a and b into your function to compute the y values. So the average rate of change would be f of b minus f of a divided by b minus a, which again, if I tie that back to the slope of a line, it would be the slope of the line between the 2 points AF of A and BF of B. So it's the same calculation that you have used in the past to compute slope. Sometimes different notation is used. So this is one way to express it. This is another way to express an average rate of change. Okay, so now let's try an example with numbers. So the problem is to find the average rate of change for f of x equal to x squared minus 3 between the values of x equal to -1 and x equal to 3. So this is a quadratic function, but there are 2 points on that on the graph of that at -1 and at 3. We need to find what f of -1 is and what f of 3 is, and that will be the difference of those two will be the numerator for the average rate of change, and the denominator is just going to be 3 minus -1. So that's exactly what I need to compute. So when I calculate f of 3, you plug in the 3 where the x is, so I get 3 squared minus 3 minus -1 squared minus 3. This whole thing is in parentheses because this minus belongs to f of -1, so I need to calculate that. So 3 squared minus 3 is 6, and the second computation is -2, so it's minus -2. The denominator becomes 3 plus 1, so I'm left with 6 plus 2 is 8 divided by 4, and 8 divided by 4 gives me an average rate of change of 2. Okay, so here's another example here in green. Given the graph of y equal to 1 over x, find the net change from x equal to 2 to x equal to 4. And then part B says to find the average rate of change from x equal to 2 to x equal to 4. So net change was discussed in an earlier lesson, and the net change is just going to be the difference in the two y values. But I need to figure out what the y values are when x is 2 and x is 4 for this given function. So you can plug them in to the function, or you can read the graph. It's probably easier to plug in x equal to 4 first, minus x equal to 2 seconds. So I have 1/4 minus a half. Again, I'm just using that function value. So it's the same values that you get here. So when x is 4, that y value is a quarter. And when x is 2, that y value is a half. So I need to subtract these two numbers, so I need a common denominator. So the 1/2 gets multiplied by 2 over 2, so it becomes 2 over 4. And 1/4 minus 2/4 gives me a net change of -1/4. So net change, that's your formula that you need to use. Now the difference is with average rate of change is that I need to take the net change, that's going to be my numerator, but divide it by the difference in your x value. So I already did the work for y sub 2 minus y sub 1. This works out to be -1/4. It's what we got up here. Divided by my denominator, which is 4 minus 2, that equals 2. So -1/4 divided by 2 is the same as -1/4 times 1/2. So you change division to multiplication and take the reciprocal of the second number. So the 2 becomes a half. And that gives me an average rate of change of negative 1/8. Okay, so linear functions have a constant rate of change. So the rate of change will be the same. That's what a constant means. It's not going to change anywhere on the line. And so if I asked you to find the average rate of change for y equal to negative 2x plus 3 for the following values of x, the answers that I get, because this is a linear equation, should be the same no matter what these values are. So I'm going to show that to you in these examples. But I expect that that average rate of change is going to be negative 2. Whatever that slope is of your line, which is the coefficient of x, should be the answer for all of these calculations in part A, B, and C. And that's only because it is a linear function, not a quadratic like the first example I did, not or the second example I did, and not a rational function like the third example. Okay, so here's my average rate of change using these two values. So it'll be negative 2 times 1 plus 3 minus, and now is when you plug in the negative 1, minus negative 2 times negative 1 plus 3 over 1 minus negative 1. So that works out to be 1. This whole thing is 1 minus 5. So that's what you get here. And the denominator becomes 1 plus 1. So 1 minus 5 is negative 4 over 2. So this becomes negative 4 over 2, which is where I get the answer of negative 2. And same number we have here. I should get the same answer for x equal to 0 and x equal to 3, part B. So you plug in the 3 first, and then you plug in the 0 over 3 minus 0. That gives me negative 3 minus 3 over 3, which is, this is negative 6 over 3, which again gives me an answer of negative 2. Again, that is expected because it is a linear function. Your average rate of change will be the slope or the coefficient of x when your line is in the form mx plus b. That's the slope-intercept form of the line. Now, part C says to find the average rate of change for x equal to 2 and x equal to 7. Plug in the 7 first, then plug in the 2. That gives you a result of negative 11 minus negative 1 over the denominator, which is 7 minus 2, it's 5. So the numerator, negative 11 minus negative 1, that works out to be negative 10 over 5. And so that's where we get our answer of negative 2 again. Okay, so the average rate of change of a linear function will be your slope. All right, so now we go on to the next part here. It says for any values of x, this is just repeating what I just said. For any values of x, the average rate of change will always be the same on a linear function, and we call that the slope of the graph. Okay, so if you're asked to calculate the average speed of an object that traveled some distance d of t over some time interval from t sub 1 to t sub 2, then another interpretation of average rate of change would be an average speed. And so that would be the difference in d of t sub 2 minus d of t sub 1. These are just two different values of time divided by t sub 2 minus t sub 1. So this is actually another slope formula, just expressed with different variables. So this would be like the change in y, and this would be the change in x. So it's just a different way of expressing that. So here's an example. It says, suppose that a car travels d feet in t seconds, and the distance is defined by the function d of t equal to 2t squared. Find the average speed over the time interval from 1 to 3. So this is basically your t sub 1, and this is your t sub 2. So when I plug it into this formula, you plug in 3 first into your d function minus, and then you plug in 1. So, and so that'll be your numerator. 2 times 3 squared minus 2 times 1 squared over the difference in your t values, 3 minus 1. So that leaves us with 18 minus 2 over 2, which is 16 over 2 for a final average speed, which is an average rate of change of 8 feet per second. So that's it for this lesson. Good luck.